Hey guys, so welcome to my YouTube channel, and this is my first ever video on YouTube. Let's see how it goes. And my intention of creating this YouTube channel is I'll be solving daily lead code problems along with upsolving the lead code as well as code chef code forces contest to my best as possible. And I'll try. Not sure, but I'm promising myself to upsolve all those. And also to teach people who couldn't solve the problems in contest and they want to solve other times but still they cannot understand the solution provided by the code chef. Here is the solution for this problem: perfect squares. Now let us see the problem statement. So given an integer n, return the least number of perfect square numbers that sum to n. As per my previous intuition, or many of them who have solved this problem, by the way, you will be having one thought that it can be solved by using a similar approach of the problem called minimum coin sum. So given a target x and you have coins ABC, and we need to find minimum coins to raise the possible uh, minimum possible coins to raise the target X. So yeah, that is one good solution. But since I've always thought of teaching you the most optimized solution, and by the way, this is kind of a top box problem. So usually we'll never get these type of questions during coding rounds or so. Let us see the solution for this problem. So for this problem, there comes into the picture called theorem called Lagrange's four square theorem. What it states is every natural number can be represented as a sum of four non-negative integer squares. Okay. If a number can be represented not in the form of this, then it will be sum of three perfect squares. Okay. Now let us maximum answer will be 4 and minimum can be 1. So let us start with eating each number case. How can the answer be 1? The number itself is a perfect square. So I'm just checking if is perfect square, then it is 1. The next thing is can it be combination of two squares? Addition. Okay. So for that, what I have done is I found math.a, which is math dot square root of n, which is a. Let's say the number is 35. The square root will be 5 point something. So I need to iterate up to 5. How could I iterate up to 5? So for I in range 1, comma math dot seal of a. Math dot seal refers here, and 5.8 it goes for 6. So for I in range 1, comma math dot seal a, b is equals to I square. If the other number is the remaining number is also perfect square, then answer can be 2. So is perfect square of n minus I into I, return 2. Now there goes the case 2. Now let's go for case 3 and 4. So answer can be either 4 or 3. So I should check if the number is of this form or not. So how can I do? First I will divide the number with 4 as many times as possible, and then divide it by 8. So if I want to divide it by 4, um, there is two approaches. One is using mathematical operator, the other is using bitwise operator. So there is this special property in the bitwise operators, and by the way, bitwise operators are too fast compared to mathematical operators, so that's why I'm going with bitwise. So uh, why? So there is let's say a number n and a number x. Let x be the power of 2. We can say n can be divisible by x if n and x minus 1 equals to 0. There is simple proof for that which takes around 1 or 2 minutes. You can even search it on Google or some other articles. It will be just mathematical. It's just a proof, I mean. So if we do n and x minus 1, if it gives 0, then n is divisible by x. So I will do as many divisions for 4 as much as possible for this number. So while n and 3. So while n is divisible by 4, I'm dividing the number by 4. How this works as divisible by 4, dividing 4, because when n is right shifted by 1 bit, then n is divided by half. When I do by 2 bits, then n will be divided by 4. So first I'm doing this operation, and then we are left with 8m plus 7. Now I will do bitwise operation. We will do division with 8. 8 is also 2 power, right? So we can do again n and 7. If the remainder is equals to 7, return 4, else return 3. And when I submit this, you will be getting answer. Yeah, this is the correct solution. So once again, thanks guys. Thank you for watching. Have a great day.